again, in this lesson we're going to be making the line of best fit for a scatter plot of data. So the data set we have here are the years past age 30 and the number of hairs, gray hairs on Mr. Capretto's head. So each number here in the top row is part of our X data, and the second row there will be our Y data. So even though this is a 3, this is really age 33, so we'll keep that in mind, but it'll be easier to graph if we just graph years past age 30. Okay, so the first thing we're going to do is go ahead and make a scatter plot of that data. So this next portion is going to go a little bit fast because this is not a lesson on how to make a scatter plot, more about the line of best fit. So we'll catch you on the other side. Alright, now that we have our scatter plot created, it's time to create a line of best fit. We want to keep some of the points above the line, some of the points below the line, trying to kind of balance it, going right through the middle. It's actually be easier if I could put a ruler on this, but I can't really do that with my tablet. So I'm going to try to go through 2 points that I think represent the data. So I'm going to try to go through this point here and this point there. I think that'll go through the data fairly well. Ugh. Yours will be much nicer with a ruler, but something like that. Okay, so I've selected this point here and this point here to be the points that go through my data. So that's for my table, that's going to be the point 1060 and the point 3250. Okay, so when we go to write our equation, I'm going to write these points down so we can see them. 1060s are 1 and 3250, double checking, 3250 are our points. Great, so now like any line, anytime we're given 2 points and we have to write an equation, we're going to find the slope first. So m equals y2 minus y1 over x2 minus x1. Y is on top. I'm going to take 250 minus 60 all over 30 minus 10. So in the numerator there we have 190, and in the denominator we have 20. So we'll go ahead and divide that. That'll be 9.5 rather, sorry, 9.5 is going to be our slope. Great. And now we're going to go ahead and use y equals mx plus b to find the equation for our line, and we're going to go ahead and I'm going to plug in the 1060. So 60 for y equals 9.5 for m times 10 for x. We don't know b yet. Alright, so that's 60 equals 10 times 9.5 is 95 plus b. I'll subtract 95 from both sides, and I get negative 35 equals b. So my final equation is y equals 9.5x minus 35. We could talk about some limitations of this equation. Clearly, I never had negative gray hairs, so that line of best fit, and we can kind of see here the line's going below the x-axis, the x-axis right here, so it doesn't quite hold up right at the beginning, but it's a reasonable line of best fit for our data. Okay, so we're going to use this to predict how many gray hairs will be on Mr. Capretto's head at age 70. So at age 70, that'll be 40 years after I'm 30. So x will be 40 for this example. So we'll go ahead and plug that in. Y equals 9.5 times 40 minus 35. So that's going to be equal to 38 minus 35, not 38, 380, there we go. 380 minus 35, so y is equal to 345. So at age 70 we'd expect 345. If we go up to our graph and look at 70 would be at 40 here. Yeah, we're probably in that range. Might be a little bit low. My graph line might not be perfectly straight either. So that estimate looks fairly reasonable based on our graph as well.